I want to leave you with some parting thoughts on how to compute stationary distributions. So my suggestions, or kind of my recipe, is you start with the stationary measure, which is not necessarily a distribution, and you try to check either local balance or global balance conditions. Before doing it, you may just want to kind of run a sanity check on, ask yourself, what do you think will happen after a long time, right? Maybe the chain will get into an absorbing state, and then it's easy to find what the stationary distribution is, or I should say a stationary distribution, because it may not be unique. So use your intuition, and you could even try to make a guess, and then try to verify one of these equations. That's going to be kind of my hint number 3, or suggestion number 3. But otherwise, if stuck, then you just kind of pick one of you get one of the answers for free, right? So mu 0 equals 1 is something I always pick, and 0 doesn't 0 does not necessarily have to be a state, right? I'm just saying pick any state, and you can set that mu to be anything you like. So try to make a convenient choice, and then try to write out equations for the second state, for the first state, for the second state, and so on and so forth, until you maybe start seeing a little bit of a pattern. You could write these equations, you could start with these local balance equations and try those to see if they get you anywhere, or you could go for the sure thing, right? This is the sure thing, but it's harder. And why is it that the case is? Well, the point is that all local balance conditions imply global balance, right? So we've shown this before. If mu satisfies this, then it definitely satisfies that. The converse is not true. And so you can kind of try this to see if you get away with it, and if you don't, then you have to kind of go with the big guns. And then finally, how do you actually get pi? Well, you divide by the sum of the mu's, right? And that's just a normalizing procedure that you should make sure that you understand that pi sums to 1, right? So, and that's the desired property. It's a required property of a distribution in general, right? That the sum over x equals 1, and that's easy to see. And then finally it sums to 1, and it also satisfies either one of these two, right? So if mu satisfies star, then pi defined in that way must satisfy star. Why? Because we can divide this both sides of this equation by any constant, including the sum over all the mu's, and still get the same exact equation to hold. And so mu satisfies star means pi satisfies that same local balance relation. And identically for global balance, if mu satisfies double star, then pi satisfies the global balance, right? Double star equations. And that's again because I can divide this side by a constant and this side by a constant. And that constant in my case is going to be the sum over the mu's, and that will show that pi is the right function that you want. So that's about it, and hopefully this helps in the next time you have to compute a stationary distribution of a chain.